Graphical representation of motion. So we will be dealing with three types of graphs basically in the entire chapter. It will be displacement time, velocity time, and the acceleration time graph. Let's start with the first example. So if the graphs look like this, what will be the type of motion which the particle is undergoing? So on the extreme left, we can see that the displacement time graph is a horizontal straight line. The velocity time graph is actually a zero line. Acceleration time is also a zero line. Hence, we can deduce that the displacement is a constant value, velocity is zero, and acceleration is also zero. Hence, we can deduce that all the three graphs represents a particle which is not moving, a stationary object. So this was the first example. Example number two, let us consider another set of displacement, velocity, acceleration, time graphs. So as a student, can you deduce what kind of motion the particle is doing by reading all the three graphs? Let us analyze. Displacement time graph is a straight line passing through the origin. So displacement is continuously increasing, but velocity time graph is a horizontal straight line, which means velocity is constant. Now we already know when the velocity is constant, acceleration will always be zero, since acceleration is the rate of change of velocity. Hence, this set of graph represents a particle which is moving at a constant velocity. To summarize, we can say that the displacement is increasing, as you can see in the displacement time graph. Displacement is increasing, but at a constant rate. Since the graph is a straight line, that is why the rate is constant, the rate of increase of displacement. Velocity, on the other hand, it's a constant and positive constant. And of course, acceleration will be zero. And that is why this set of graph represents a particle which is moving with a constant positive velocity. Now, let us consider another set of graphs. So, can you read these graphs and determine what kind of motion the particle is doing? So, if we analyze the displacement time graph, it is a straight line, but the displacement value is decreasing with time. Velocity is a constant, it's a horizontal constant. But unlike the previous example, the velocity is below the time axis. So, in this case, velocity is although constant, but it is negative, which means the particle could be moving towards the left hand side with a constant velocity. And since the velocity is constant, acceleration will, of course, be zero. And if we summarize all the three graphs, we can say displacement is decreasing at a constant rate, velocity is constant but negative, and acceleration, of course, is zero, which means all these graphs represents a particle which is moving with a constant negative velocity. And finally, let us consider the last set of graphs which we will analyze. So let's see what's going on here. So displacement is definitely increasing, but it is not increasing at the constant rate, as this graph is not a straight line. It's a curve. Displacement is actually increasing, but increasing at a faster rate as the time passes by. If we analyze the velocity time graph, it's a straight line passing through the origin, which means velocity is increasing, but at a constant rate. And why constant rate? Because the graph is a straight line. Unlike in the displacement time graph, which was a curve, there the rate of increase of displacement was increasing with time. And finally, coming to the acceleration time graph, it's a horizontal straight line, which means this set of graph represents a particle which is accelerating at a constant value. So let us summarize. Displacement of the particle is increasing, as you can see in the graph, but it is increasing at an increasing rate. Velocity is increasing, but at a constant rate. Acceleration, on the other hand, will be constant and positive. To conclude, all these graphs represents a particle which is moving with a constant positive acceleration. And of course, the velocity is increasing. So in the exam questions, if the graphs are given, we can easily read what kind of motion the particle is doing. So the next topic is finding the displacement, velocity, and acceleration graphically. In this concept, if the question has given us the displacement time graph and we are supposed to find velocity, so the trick here is all we need to do is figure out the slope. So the slope of the displacement time graph will give us the velocity. To be more specific, it is instantaneous velocity. To summarize, we can say gradient or the slope of a displacement time graph gives instantaneous velocity. Similarly, if the exam question gives us a velocity time graph and we are supposed to find acceleration, all we need to do is just figure out the slope. So the slope of the velocity time graph will give us acceleration. To be more specific, it is instantaneous acceleration. And hence we can say gradient or the slope of a velocity time graph gives instantaneous acceleration. Let us understand this logic with the help of a diagram. So here we have a displacement time graph. The x-axis is time, y-axis is displacement. And let's say the graph looks like this. It's a straight line passing through the origin. So this graph is, let's say, for the particle A. On the other hand, there is another particle B which is moving, but the graph for that looks like this. So both these graphs are straight lines passing through the origin, but the slopes of A and B are of course different. If you observe carefully, the gradient for the particle A is much higher. So it is a high gradient, which means velocity will be high. Because remember the logic, gradient of a displacement time graph gives us velocity. So if the gradient is high, so does velocity. On the other hand, the particle B is having a lesser gradient, which means it will have a lower velocity. And this is how we read graphs in the exam questions. Similarly, let's say in an exam situation, we are given a velocity time graph. So let's say the graph looks like this for particle A, and for particle B, the graphs look like this. So we are going to follow the same principle by recalling the logic that gradient of a velocity time graph gives us acceleration. Particle A graph is having a higher gradient, which means acceleration will be higher. For B, it is having a lower gradient, so acceleration will be low. And in the exams, all we need to remember is the gradient of a displacement time graph will give us velocity, and gradient of a velocity time graph will give us acceleration. Let us solve the question based on this principle. So here we have a graph. On the x-axis, it is time. On the y-axis, we have distance. The graph shows how the distance run by a boy varies with the time. And we are supposed to find the instantaneous speed at 2 times 5 seconds and 20 seconds. Instantaneous values, if you recall, is the gradient of the graph. Since we are supposed to find the speed, instantaneous speed at 5 seconds, so all we need to do is figure out the gradient of this graph at this point. Since the graph is a straight line while it is passing through 5 seconds, that means all we need to do is figure out the slope of this line. To do that, we will use the gradient formula y2 minus y1 divided by x2 minus x1. So this red line is starting from this point, which is origin. So let me write down the coordinates. It is 0, comma 0. And on the other extreme, this particular point, the coordinates will be x coordinate is 10 and the y coordinate is about 48. So let's write down the coordinate of this point will be 10, comma 48. So the instantaneous speed at 5 seconds, let's write it down. Case 1, when the time is 5 seconds, we are supposed to find the gradient. We will use the gradient formula y2 minus y1 divided by x2 minus x1. So coordinates already we have established. So the gradient will be 48 minus 0 divided by 10 minus 0, which will give us 4.8 as the value, which means the instantaneous speed at 5 seconds will be 4.8 meters per second. Employing the same logic for t is equal to 20 seconds to figure out the instantaneous speed at 20 seconds, which is this point, we need to find the gradient of the graph at 20 seconds. Now the graph is a straight line while it is passing through 20 seconds, which means all we need to do is find the slope of this line. One extreme of this red line is 10, 48 only, and the other extreme will be this point. What will be the coordinates of this point? So x coordinate is 30 and the y coordinate is 90. So let's write down the coordinates of this point as 30, 90. So in the second case, when the time is 20 seconds, let's figure out the gradient. So it will be 90 minus 48 divided by 30 minus 10. So let's write it down. 90 minus 48. So this is y2 minus y1 divided by 30 minus 10. And if we simplify this, we will get 42 divided by 20, which is equal to 2.1. That means the value of instantaneous speed at 20 seconds will be 2.1 meters per second. Now, for the B part, we have to find the average speed for the entire 30-second run. Average speed is the total distance traveled divided by total time. So for the B part, average speed, let's write down average speed is total distance traveled will be the numerator and time taken will be the denominator. So the boy starts from 0, 0, that's the start point, and finally it reaches this point when the value of distance is 90. So the boy has traveled a distance of 90 meters in how many seconds? The total time is 30 seconds. So average speed will be 90 divided by 30, which will get us 3 meters per second. And now you can clearly observe that the value of instantaneous velocities are not the same as the average speed. For the first 10 seconds, the instantaneous speed is 4.8, so it was moving faster as compared to the next 20 seconds when the boy was moving with a 2.1 meter per second speed. But if you analyze the complete motion, what will be that one constant speed with which we can assume that the boy is moving? That is called the average speed. which in this case will be 3 meters per second. Now, this is that same question which we had done earlier, where we found the value of average speed and average velocity. But why I have placed this question again is just to drive home a point. Let's read. We cannot use the gradient to find the average velocity. Gradient of a displacement time graph gives us instantaneous velocity and not the average velocity. And in the exam questions, be very careful. Are we finding the average values or the instantaneous values? So for average values, we have the formula average speed is total distance upon time. Average velocity will be total displacement upon time, but the instantaneous values, to find those, we always do the gradient of the graphs. So gradient of displacement time will give us instantaneous velocity. Gradient of velocity time graph will give us instantaneous acceleration.